So good morning. I am David Bowman, the Executive Director for the Four Corners Regional Education Cooperative #1. And this session today is actually our third session on Excel tips, tricks, and hacks for educators for looking at student data. We've got a lot of new folks here, or we will have a lot of new folks here today. So I'm going to spend a bit of time and review some of the strategies that we used in the first couple of sessions. And then we've got a few new pieces that will add, dealing with more of the statistical side of student data and how we can get Excel to facilitate that. So with that being said, let me go ahead and share. I will mention, however, that this video, the previous two videos, the upcoming ones are all available on our website, and you see the link down there. It's nmrec1.org/techbits. Now, as I mentioned, I'm going to spend a bit of time reviewing, particularly because we've got some new folks. But if you want a fuller explanation of some of the review items and topics, you can always pop over to that website and take a look at TechBits 1 or TechBits 2, and you'll find them there, and then eventually you'll find this video there as well. So let's jump into this. As I mentioned in previous sessions, I have spent a great amount of my career looking at student data. Originally as a teacher with students in my classrooms that I had when I was teaching high school. And then later, as I began to work more with project management and even serve as an evaluator for projects, I spent a lot of time just looking at data. And there are some things that I'm always doing to make it easy. Now, Excel is super powerful, which I totally love. Because it makes things very fast and very easy to take information that we've got and extract from it the answers to the questions that we have about the data. We want to know certain things, because if we got a bunch of numbers, they're worthless until we start asking some interesting questions and seeing what information we get out of it. That is where Excel is just superior and accurate and fast. So we're going to spend a bit of time looking at some of those strategies that I'm always using, then we'll move to the more statistical side after that. So from the beginning, the number one thing that I'm always doing when I'm looking at data, whether it's 10 lines of data or 10,000 lines or 50,000 lines of data, there's some things that I'm always going to do. To make everything easy, the first thing I'm going to do is I'm going to name my ranges. So, for example, on this set here, we've got a range for the sex of students, males and females. I can give that entire range a name, and then if I ever need to pull information out of it, I can just simply refer to the name that I give it. So let's take a moment and do that. So this is student sex. Let me highlight it all. And then up here on the upper left, we've got our name box up here. And it'll generally tell us, in this case, C5, G12, or whatever it is, and that's the Excel name for it. But I can give it my own name that makes sense. So I'm going to simply replace that and type in STD_sex. So now that entire range has its own name with some very specific information. And I can pull down my little menu. There it is. And you see that it's going to highlight that range. As we get into the techniques for pulling out information, the techniques are going to be simpler to use and easier to understand once I have done that. So let me just go ahead and get the rest of them. We're going to call this one grades. We're going to call this one, we'll call this one spec ed. And I will make one note here while I'm doing this. Just for my own sake of memory, one little trick that I like to do is I will go back and I will rename my columns with the name that I've given that range, just so I know, like, what did I call that again? Okay, that's what I called it. So I've got one called STD underscore sex. This one was called grades. This one was spec ed. All right, so let me just do ELL right quick. ELL. I'm going to call this one absences. And I'm going to call this entire range right here scores. All right, and let me rename the column so I know what it's called. Okay, so now I've got my ranges named, each of which has its own type of data. So as I do the formulas, I can just simply refer back to the name that I gave it. And it makes it easy to read and write the formulas for pulling out information, because they're going to make sense with real words. You know, if I have to refer back to C7 through C whatever's at the bottom here, that might not mean anything to me. But if I'm saying student sex, oh, I know what I'm looking at now. All right. So as I said, this is kind of a review. There's a bit more detail about that, but in a sense, that is sort of what I would consider to be the first and most important technique for making everything else simpler, because we're trying to make things easy for ourselves. If we want to make things hard for ourselves, we print stuff off and we grab our highlighters and get our calculators, and you know, that's the hard way. I like doing things the easy way. So the first thing that I'm going to want to know is, how many kids do we have here? How many lines of data that we have? And we're going to use the formula called count A. And count A means count all. So I'm going to give it a range. And what Excel is going to tell me is how many cells within that range have something in them. Count all the cells that have something in them. And I'll just grab one, student. So I'll do student sex. I could do IDs just as well, or any of them. So let me use that here. Equals count A. Now, Excel is saying, all right, there's the formula. Now give us, where are we counting, right? So I could say B5 through whatever, or I'll just say everything that's in student sex, because I've got a name for it, how many cells have something in them? 40. And what that tells me in this case is I have data for 40 kids. There are 40 kids represented here. So we'll end up using that particular number here in a moment. But, you know, that's often the very first thing that we want to know, you know, how many lines of data do we actually have? And now let's start pulling some stuff out of those data, right? We're going to start with the function that are just counting, like how many of this and how many of that. And then we'll start doing some calculations on scores and averages, and, you know, trying to combine the information. But we're going to start off with just counting. So we know how many kids we have, but let's say we want to know how many of those students are males and how many are females and how many have certain scores and so forth. So we're going to use the counting function, but there's a simple little function that Excel has that allows us to count specific items. Instead of give me all 40, tell me how many meet a certain criterion. And that function is called count if, like count the number if they meet a certain criterion. What it's going to ask me in Excel is, all right, first of all, where are we looking for the information? Okay. And the next thing it's going to ask me is, what's the criterion that we are looking for? So in a range, how many of those items meet a certain criterion? So we know we've got 40 students up here. And so we want to know how many of them are males. And let me just pop over quickly to my little drawing tablet over here. All right, so we know we've got count if, and I want to know in that range of students, in their student sex, how many of those are going to be labeled male? And then we close our formula. So that's the range. That's where we are looking. And over here, the next one is, what are we looking for? All right. Now, you'll notice I put quotation marks around this if it is a text value. It's not just a single number we're looking for. If it's a text value, we've got to put it in quotation marks to let Excel know it's not a number, it's text, it's a string. All right, so let's use that. And we'll do it right here. So equals count if. Now, where am I looking? I'm looking under the range, which I've already labeled, called student sex. And what am I looking for? Now, there's two ways to do this. There's an easy way and there's a super easy way. So let me show you the easy way first. So I'm looking for the letter M for male. And it tells me there are 21 males, which is cool. So if I want to then find females, I mean, obviously it's going to be 40 minus 21, but I could say equals count if, and I write the whole thing again like this, and I'm looking for F, and it's 19. So that's an easy way. Now there's a super easy way, which is even a little better, because one thing I don't like to do is rewrite formulas. If I've already got a formula written, let me just see if I can keep reusing it in some way. So in this case, I have said, so I've got my count if, and I've got student sex, and I'm looking for male. And if I want to look for females, I've got to replace M with F. But instead of saying, look for this string, I could say, look for whatever value is in a different cell. And you'll notice that I have already labeled these male, female. So instead of typing in M, I could say, go over to student sex and look for whatever value is right above it up there in K8. So instead of that, I'm going to say, whatever is in K8, that's what I'm looking for. And here's where it gets neat. So let me just do that for starters. So looking for K8. So whatever's up there, that's what I'm looking for. In this case, it's male, M, and it's 21. So here's something fun that Excel does. If I move that formula, it's going to refer to different place in the spreadsheet. Right now, it's saying whatever's in the cell immediately above, that's what I'm looking for. And if I move the formula over, it's still going to say whatever's immediately above, again, that's what I'm looking for. So here I'm saying look up in K8. And if I simply move this formula over to the right, now it's looking up, right up in whatever's in L8. I didn't have to rewrite the formula because I've got it referring to a different place. So when the reference changes, it's going to look for something new. So I only have to write it one time. Oops. And then just simply copy it to the right. So a simple way and a super simple way. Now, let's just do one more here above 500 because we need to do something a little different. So here we were looking for males, right? So we have little quotation marks. And you saw that I could put in a reference there. I can put in a number there. But I'm saying I want scores above 500. So scores that are greater than 500. And this is actually telling Excel two things. It's saying look for greater, and greater than what? 500. And we need to tell Excel that these need to work together. It's actually two things that we're asking. And the way we do that is just like with text, we're going to put it in quotation marks, to tell Excel these two items need to work together as a single criterion. So let's try it. So how many scores above 500? So I'm going to do count if the range, which I have named, is scores, comma, and what am I looking for? Now my quotation mark, my greater than 500, quotation mark again, and then close it. Out of 40 lines of data, out of 40 students, 23 of those students have scores over 500, which is pretty neat. And then I can do the math and just say, well, how many are less than 500 or less? And it's going to be whatever's left over, 17. So that's count if. Just how many times does this criteria get met? But what happens if we have more than one criterion? Like on the next one, you see how many students are ELL students and special ed students. Not just how many ELLs, I would use count if, or how many special ed, I would use count if. But I need to find two criteria. So we do, instead of count if, we do count ifs. And it's that S right there that allows us to string together multiple criteria. So ELL students, special ed students, let's see how it works. Count ifs with the S. And it's set up exactly the same way as count if. Count if says, where am I looking? What am I looking for? Count ifs with the S, where am I looking? What am I looking for? And now, where am I looking and what I'm looking for? I think you can string up to something like 256 criteria, but honestly, if you have 256 criteria, then you kind of need to rethink your question. I believe that's a lot of specificity, but it's possible. I don't know why you would do it, but you could if you really wanted to. Okay, so I need ELL and special ed. So criterion range 1, look in the range, which I have called ELL. And what am I looking for? So I look at the data and I see everything is a 0 or 1, which is standard. 0 means no, 1 means yes. So I'm going to look for the number 1. How many times does that 1 show up? Now, criteria range 2. And it's going to be spec ed. And what am I looking for? The same thing again. And let's close it. So, lickety split, I know that I have 5 students who are both ELL and special ed. Could I do this manually? Could I scroll down and just count? Yes, I absolutely could, but this is going to be fast and it's going to be accurate. Okay, just a quick note, link has been sent out again. All right. So was there a question, Kendra?
Yes.
Okay.
The way that you have it set up under count if, how many scores above 500, would you do a count ifs so that it was just the males because the M is right above it? We
could. We absolutely could. And actually, let's just do it. So how many males above 500? Is it like, that's what you're asking? Because now we've got two criteria.
It's in that column right now, right? It's in the male column.
Yes. Well, let's try it. We'll just do it. So, or actually not how many males, but males and females. Okay, above 500. So with the count ifs, we know that we have, come on, Bowman, count ifs. So we've got a range and we've got a criterion, we've got a range, we've got a criterion, and so forth, however many we need. So for this case, then, we could say equals count ifs, and we're going to look at student sex, comma, and I'm going to just click on that M up there. So whatever is up there, look for that, right? And I'm going to say in scores, comma, so in the range scores, we're looking for greater than 500. 12 male students have scores above 500. And I can move my formula over one. So instead of looking for males, it's now going to look for females. And there are 11. The big difference between COUNTIF and COUNTIFs. COUNTIF, you can only look for one criterion. COUNTIFs, you can look for multiple criteria. And then using that reference to say, just look for whatever's up there. And if we move the formula, look for whatever's above that and so forth, it just makes it easy so I don't have to rewrite the formulas over and over again. Well, that kind of takes care of ELL above 500 also, but I'll go ahead and do that as well. Count ifs, look in the ELL range for the number 1, look in scores range for greater than 500. Only 9 ELL students have scores above 500. So that's count if and count ifs. All right. Averaging, add them all up, divided by the number of items, right? Or your numerical mean. So that Excel does it very simply. It's just equals average, and then give it some kind of a range, and it will give you the average value. So let's do that right quick. So if all the scores equals average of scores, my average is 538.5 points. All right. So that's not very interesting, honestly. Where it becomes interesting is when we start to subdivide the student groups. We start to look at how various subpopulations compare against the overall average and compare against each other. So because we are introducing a criterion, we're going to use not average, but average if. And we're going to say range and criterion. So let's try it. Equals average if. And there is one more thing that we can add to this, which is pretty neat. And let me go ahead and put it up here. So the basic formula, just where are we looking and what are we looking for? And if we meet those criterion, average them up. But we can add a third item, range to average. We can say, look in this column over here for the criterion. And if they meet that criterion, average in this item in another place in a different range. So here, if I'm looking at 5th grade kids, for example, the range for the criterion is grades. What I'm going to look for is the number 5. And if I find it over here in this third range, this other range, that's the number that I want to average in. So I can set up a little criterion that way, which is really neat. So let's try it. Average if. So immediately after the session, I'm going to go take a typing class. All right, so the range for the criterion is grades. There it is. What am I looking for? 5th grade, so I'll put in my 5. And now, if a line of data meets that criterion, what's the number that I want to average in? And that's going to be under scores. So it's going to say, look in grades, every line that's got a 5 in it, go find the score, and those are the numbers that we're going to average up. And this is where it starts to get kind of interesting. The average score for 5th grade students is 499, which is less than the average for all students, right? So somehow, as a group, those 5th grade students are underperforming the overall average. And in this case, we've only got fourth and fifth grades. So fifth grade students are underperforming the fourth grade students. And we can do the same thing for, let's look at the ELL students. So average if, where am I looking for the criterion? I'm looking in the range I've called ELL. What I am looking for is the number 1 to indicate an ELL student. And where's the number to average? Over in scores, 521. So a little below the overall average, but interestingly, higher than the average score for fifth grade students. And that's where it starts to get kind of interesting. And then the neat thing that we're really trying to do here is, we want to be able to answer important questions and start looking pretty deeply into the data and start picking and choosing the data that we want to get out of it, that we specifically need for our questions. And it's these kind of techniques, average if, ifs, count if, and so forth, that make that possible. So let's just go up one on that. So average if, like count if, you get one criterion. If you have multiple criterion, average ifs with an S, and it's going to look pretty much the same, except things are in a bit of a different place. So first thing it's going to say is, where is the average range? Where are the numbers that we're averaging up? And now we do the criterion range and the criterion, and then the next criterion range, criterion, and the next criterion, and so forth, and we can keep stringing them out. So the only difference in the way the formula is built is the first thing we're going to do is tell it where's the number to average, and then where are all the criteria. And we're going to do something a little tricky with this one, having to do with how do we move formulas around and still have them work the way that we want them to work. So the basic piece, so let's just do fourth grade males first, and then I'll show you how we can change the references, so no matter where we put this formula, as we drag it around, is still going to give us the right information. So average ifs with an S, and it's going to say, all right, where's the range that we're averaging up? We're going to be averaging up the items in scores. And where's the first place we're going to look for the criterion? And we've got student sex, and I'm going to go ahead and refer up to the M, because I'm already thinking ahead. I'm going to move this over to females, and I'm going to move it down from fourth grade to fifth grade. So let me go ahead for now and say, in student sex, we're looking for whatever is immediately above it, K24, which is an M. The next criterion is the grades. And what am I looking for? What I'm looking for is the item that's over to the left, which is kind of getting covered up right now, which is where I have the student's grade. So whatever's over there in J25, that's what I'm looking for in the range grades. And close it and end it. So male students in the fourth grade, the average score is 535.1, which is almost exactly the overall average, which is kind of neat to me. So I know that I can take this formula now and I can move it over one to females, right? So instead of whatever is in immediately above for student sex, M, I'm going to move it over one, and it's going to look immediately above, and it's going to find an F, so it'll look for F. So it will work for student sex. So let me move it over. But it receives an error, which we need to fix. And the problem is, when we've moved that formula over one, it's still going to look immediately above to see what student sex are we looking for. But we also referred over to fourth grade, over to the left by one. It's still looking over to the left by one, which means it's not looking at the grade anymore. It's now looking at this value right here. So we need to tell Excel, look, even if we move this formula over, we still need the value that's not one back, but 2 back now. The value that is still in J. Regardless of where I move this formula, I need the value that's over there in column J, which it's not doing currently. And that gets us to something called absolute references. So let me just take a moment. Let's get rid of all of that. Okay. So a reference is going to look like this. Let me turn that back on. Let me just empty it out. Okay. So we have a reference. Let's say it's J12. And it's going to say, look, whatever's in J and row 12. And if I move that formula over 1, it's now going to look in K12, because it's going to take that reference and move it over 1. But I don't want to do that. I still need J. Well, there's a way to tell Excel, even if I move this formula around, I need that J to stay the same. And it's pretty simple. So instead of this right here, I'm going to say J. So there's my J12. This number J has to stay the same. And the way we do that is we put a $sign in front of it to say J is absolute. Absolutely, no matter where else I'm looking, that's where you got to be. Now, if I take this formula and move it down, we're still going to have J, but it's going to go down to the next row, which means 12 is going to become 13. Well, if I want that 12 to stay the same, I'm going to do the same thing. J 12. So even if I move it down, it's still going to be 12. I've turned this into an absolute reference right here. So we have to kind of think ahead about where we are going to put this formula. We can always rewrite the formula, retype it, but that's inefficient. And Excel is supposed to be efficient. So we have to think ahead, where am I going to end up moving this formula? And do I need to make any part of those references absolute references? Well, we do, because obviously it didn't work, right? So I know that I'm going to move this formula over to the right. So, and I'm going to be moving it down. So let's think. So I know the grade. So right now it's saying whatever's in J25. I know that's going to change, but it has to stay in column J. So I'm going to put a $sign in front of the J. So no matter where I move it, still look in J. Now, do I need to do anything with that 25? No, because row 25 has 4th grade, and I'm going to move it down to 5th grade. So I need J25 to become J26, because to go over and see not 4, but 5. So I'm going to leave it just like that. Now over here, we've got student sex. And we know that right now it's looking up 1, which is K24, and I'm going to move it to the right, which will give me L24. But I'm also going to move this formula down, which is going to give me K25 and L25. That's not right, because that male and female, no matter where I put this formula, that male and female is always going to be in row 24. So even if I move it around, I still need to make sure I'm looking at row 24. So I'm going to put my $sign in front of 24. And I'm going to show you how we can even make this easier, honestly. But let's see if it works for starters. All right. So I'm going to move it to the right. Male is going to change to female, but the value over for the grade is going to still be in J, and it now works. Wow, the girls really outperform the guys in this one. Cool, good for them. Now I'm also going to move it down. So we're going to go from line 25 to 26, 4th grade to 5th grade. but male is still up there in the previous one. So let's move it down, 575, and I can move it across. And now all the references work. So this one is referring to 5th grade and up to row 24 for the gender. Make it a little easier now. So let's pretend like all these aren't here. I'm going to simply copy across, copy down, and it's done. 2 keystrokes, and I've got male and female 4th and 5th grade scores. Lickety split and accurate. So as we think ahead with the data and what we're trying to find out, we have to consider, are we going to move this formula around, and are there some things that should not move? And if they should not move, then we put that $sign in front of them to say that part absolutely needs to stay the same. So it's just a thinking issue. So that makes it quick. Oh, all right. Let's just do one more. Well, we did it. So that's average ifs. The last one that we have dealt with as we're reviewing is something very cool called sum product. And it is little known and little used function of Excel, but it is super duper powerful and so useful to me when we're looking at data. So far, when we did counting, we're just saying how many times does it come up, right? How many times do we have 4th grade? How many times do we have ELL? Just give me the count, the number. But what if we want to add up the value of the items that meet those criteria? Not how many times those criteria are met, but the values represented by those criteria. And for that, we can use something very cool called sum product. Here's what sum product is going to do. And it is what it says it is. Sum, adding, right? The sum of these things is add them up. Product, a product is the result of a multiplication formula. If we say 2 times 3, the product is 6. So we're going to do some multiplication to get those products, and then we're going to sum them. We're going to add them up. And this is going to allow us to pick out some values that we're interested in that meet a variety of criteria. And here's how it works. Let's get rid of that one. Okay, so I've got a little sample chart here. All right, so let's say we are looking for male students. Come on, type. Why am I not typing? Male students, turn that back on. Come on, Bowman. We don't want that one. We want this one. Let me just drop a new thing in there. Okay, so we know we've got male students, and we want 4th grade male students, and we want to know what is the sum of their scores. Or actually, for our example, we're going to be looking at absences. So let me just put in absences. I have fat fingers, apparently. Come on. How many absences? So the way it's going to work is this. With sum product, it's going to look at each line individually, and it's going to do a little multiplication. So in this case, we know we want male students in 4th grade. So it'll look at the first item, and it'll say, does that equal M, male students? If it is, give it a value of 1. Now look at the next one over here. Does that meet the criteria? And if it does, give it a value of 1. And now, what's the value over here? And it's going to multiply across. So it's going to do 1 times 10 for 10. It'll do the next one. Male, that is not, female is not male. So we're going to give that a value of 0. 5th grade is not 4th grade. Give that a value of 0. And over here, that's a value of 12. So we're going to multiply 0 times times 12, which is 0. And it's going to do over here. Let's see. So that's a 1. Give that a 1. Give that a 1. Times 11. So that's going to be 11. Female, that's going to be a 0. Fourth grade is going to be a 1, and that's a 12. 0 times 1 is 0. Times 12 is 0. And it's going to add them up, which will give us 22. So we do the multiplication to get a product right here, and then simply add up all the products. And what that's going to tell us in this case is how many absences do male fourth grade students have? Some product. It lets us pick and choose very specific criteria to include in our total value. So let's try it. And it's going to look like this. So equals, it's going to be some, let's do it here, some product. And then each of those criteria are going to be inside their own parentheses. So we're going to look for, in this case, student sex equals male. What do we actually, average score? No, it's fifth grade ELL. So we're doing fifth grade ELL. So grades, is it a 5? We're going to multiply that by the next criterion, also in its own set of parentheses. We have ELL needs to be equal to a 1. There's our next one. And then once we've done that, simply multiply by absences and close it. So we can string together all those criteria and then add them all up when we're done. So let's see what it does. Total absences by fifth grade ELL. Some product. The first one's going to be grades equals a 5. The multiply that by ELL equals 1. And then if we meet those two criterion, we're just looking at absences. Fifth grade ELL students have a total of 13 absences. And you know what? I'm going to do something a little better. We have male and female up there. I didn't ask for that, but let's say we wanted to add male in there also. So I can just add another item to this. And so we're also going to look at student sex equals whatever's above it times that. So now we've got fifth. Oh, I know why I didn't do it, because I'm going to change it. So fifth grade ELL males, fifth grade ELL females, 7 total items. So there's another function. This is new. We didn't do this in the last couple of sessions, called sum ifs, which is going to do the exact same thing. Sum ifs is going to be sum ifs, and it's going to ask me for a range, criterion, range, criterion, and so forth, just the way the other ones are strung out. And it's going to give us the same result. So why do I like some products? For 2 reasons. One is when I'm going back to look at the formula, the formula itself tells me exactly what it's doing. Is this equal to that? Is this equal to that? Is this equal to that? So going back to double check it and see what I'm actually doing, it becomes very easy to understand what is the end result telling me. But there's also something that some product can do that some ifs cannot do. And I will show you that in a moment. But let's go ahead and do some ifs for now. So equal some ifs. Where is the range that we're going to add up? We are going to be adding up absences. Criterion range. What's the first criterion? It's going to be grades, comma, 5, comma, ELL is the next range, comma, 1, and then we close it. Oh, we also have student sex. Student sex. comma, whatever's above it, and there we go. So the number is going to be the same. It just reads very differently because it's this, that, this, that. It doesn't give me like equals, less than. Some product can do things like this is less than that. This is more than that. And the formula itself is going to write it out exactly what I'm doing. So I like it better. But there's another option. So what can some product do that some ifs cannot? Sometimes we don't have criterion. We just want to know all the values in one column multiplied by all the values in the other column. So you'll see we've got, and I'm not sure exactly why you would do this, but so I've got how many ratings and how many stars are of that rating. So we've got, in this case, 3 ratings have 5 stars, 10, or maybe it's the number of students, right? Let's change that. 3 students have 5 stars, 10 students have 4 stars, 2 have 3 stars, so on like that. So these slow and inefficient ways to say, well, if I need to know how many stars, in this case, have I given out completely, I can say 3 times 5. So that line is 15 stars, and I can copy it down. All right. And then I have to go back and add them all up. All right. And there's my answer, 62 total stars. But this is just replicating what some product already does. So why don't we use that instead? So I will say equals some product, this range, times this range. 62. So it's a little faster, but it's something that some ifs cannot do. Woo! Has anybody exploded yet? Just double checking. How does it know to go to the left? And I'm sorry if this was an older item.
That was for the, if you scroll up a little bit, it was for yeah. So for the average ifs.
Mm-hmm.
So when you're in the male, how does it know to go to only 4th grade males?
So when we started what we called relative reference, relative to where the formula is, go up and go over a certain amount. And if we move the formula, it's still going to go up the same amount and it's still going to go over the same amount. So if we start right here with males, and let me blow that up a little since we're talking about just this one. So here we are. The original formula says, all right, for the gender or the student sex, go up 1. And for the grade, go over 1. When we don't declare those as absolute, if we move the formula, it's still going to say go up 1, and it's going to say go over 1.
Yeah, I understood that change.
Okay.
Where did you put the original directions to go up 1 and over 1? Like, where did you set that up in the Excel?
Right there, K24 and J25. So here in the original formula, K24 and J25, it's referring to a specific cell, but when Excel reads it, it's ignoring J25 and K24. What it's saying is where does that exist relative to where we are right now? All right, so we call it K24, J25. Excel reads it as up 1 and over 1. So if we move it, it's still up 1 and over 1, which is why we had to put in those $ signs to say, don't go over 1, always go to this row, always go to this column, regardless of where
that's inherent to Excel. It'll always go up 1 over 1, or you had to put it in somewhere.
So when I put it in, so like here's the original K24, it's because I put in K24, and where is K24? Up 1. If I put in K23, you'll see now it's looking, see how it's highlighted the next one up? So relative to the formula, it's up 2. Or if I put in 22, it's up 3. So Excel reads that initial one and says, where does that exist relative to where we are right now? And it figures out it's 2, it's 3 away, it's 4 away, or so on like that. So Excel already will automatically do that. The reason why initially, let's see, what do we start with? 24. The reason why it said go look up 1 is because that cell I've designated is up 1 from where the formula is. Or
Okay, thank you. That
up
makes
2,
sense.
up 3, or up 4, or whatever, up however many it needs to be. So Excel just takes that and then figures out where that placement is. Is it 1 up? Is it 2 up? Is it 3 up or down, right? And then when you move the formula around, it keeps that same relative to position unless you specifically tell it, don't move this with that $sign. K must always be K. 24 must always be 24. Otherwise, it'll just automatically move where it's referring to, which is why they're called references, variable references. Does that help? I'm going to cross my fingers.
Yes, thank you.
Okay. Well, it takes a little bit of pre-planning. If you already know you're going to be moving some formulas around, move them to the right or up or down in order to build a little chart like this. You just have to pre-plan it a little bit. Like as I'm putting in where I'm looking, does any part of that need to stay the same? And if so, you just add that $sign in there and it will say, okay, that part of it, the reference is absolute. The other part can change. That part's the same. I will throw in, I'm looking at the time. I will throw in one little trick though. So here's my K24. There's a way, if you're like me, I go shift 4 to get my $sign, but I'm often getting the hashtag or something. You can just hit your F4 key and it'll say, okay, everything is absolute. Hit it again, the second part, hit it again, the first part, hit it again, and it cycles around. So that F4 key will cycle around where those $signs are being placed. And in this case, I wanted 24 to stay 24. So just a little keyboard shortcut, F4 key will cycle through the different options. All right. Wow, I am looking at the time. So let me bang through just a couple of items that are just flat out crazy simple. We've already done averages. So here we've got times and scores. So let's call these S scores. Let me just name these very quickly. So that range is called times. And this range we're going to call S scores. Okay, that'll make it all easier. Average is simple. Give me the average time. Oh, the average scores. S scores. The average score is 469.76. What's the highest value? Highest is easy. It's just equal max. And then what's the range we're looking in? And that will tell you what's the highest value in that range. So equals max. And let's look at S scores. The highest value is 571. Minimum is almost exactly the same. What's the minimum value in that range? So max and minimum, really simple, right? Equals min scores. The lowest value is 336. So what's the range? I could just say now equals that minus that. So what's the maximum minus the minimum? The range is 235. But I can do something a little, if I don't want to have to do the maximum first and the minimum, I don't care. What I really want to know is the range. Well, then I just write my formula a little bit differently. I will say the formula will be max minus min of that same range. So I can write it that way instead of this already found out maximum score minus this already found out minimum score. I'll just write it like that. Max of scores minus min of S scores and 235. Let's do two quick things, and I'm gonna one for sure. Then I'm gonna ask you if you can bear with me for a couple of minutes to do something else also. One thing we often need to know is what is the standard deviation of the values, because that's going to tell us something very important. The standard deviation is going to tell us, are all of the values pretty tightly clustered around the mean, or is there a great amount of variation? If there's a great amount of variation, what we generally find out is that we can't draw any conclusions about the average. If we've got we calculate an average and all the scores are pretty clustered, we can say, all right, that's fairly representative of the overall set of data. So great. But if we've got an average and a really big standard deviation, a lot of variation, then that average is kind of meaningless to us, right? I mean, that's one of the problems when we look at big data sets for the state. We say, wow, fourth grade kids on average are at the 3.8 grade level. Okay, well, that's cool, but the standard deviation is huge. So the average is meaningless. It's like, yeah, that's the average, 3.8, but the kids are all the way from first grade to sixth grade. So the average doesn't give us any value. And the way we figure that out is by calculating the standard deviation. So just for the sake of giggles, let me see if I can represent that. So here we've got 3 standard deviations. We have 3 data sets. Same scores, same number of scores, same average. Here's our average right here. Same average. Where am I? Sum product standard deviation. Okay. Same average right here. But you see in this one, in the blue one, those scores are pretty tightly clustered around the average. So knowing the average is important. In this, I don't know, teal, the standard deviation is bigger, so we have to be very careful about the average because it's not really representative of the whole population. And this orange one down here, the standard deviation is much bigger. The scores are just spread out all over the place. The average is meaningless to us, right? Because it's not really representative of the population as a whole. So whenever we're looking at averages, one thing I'm always going to do is say, well, what's my standard deviation? And then from that, I can decide, is the average useful to me or not? So we calculate, and Excel makes this crazy simple. Once upon a time, when I was tutoring stats for UNM, I had all these formulas memorized and I could write them out on the chalkboard, a very big chalkboard with a lot of chalk. Or I could just do standard deviation and what's the range. And Excel will give me the same value. So let's say we want the standard deviation of the scores equals STDEV, standard deviation. Oops, I apologize for that. Let me fix that. Standard deviation, that's it right there. And the range is scores. The standard deviation is 60.9. Now, when Excel calculates standard deviation, it assumes that we are looking at a sample of the overall population. So, for example, if we're conducting a study and there are 20,000 people in town and we survey 500 of them, that 500 is just a sample of the overall population. So the formula is slightly different. But if we've got the data from the entire population, like if it's a class of kids, or we have all the third grade students for the district, and I've got every single score for every single kid, then I'm not looking at a sample. I'm looking at the entire population. The way we tell Excel this is everything is we add a P, standard deviation of the population. Otherwise, it's going to assume a sample. Does it make a big difference? Well, depending on the data set, it can. But let's just go ahead and put it in there. STDEV P for the entire population. And the range is scores. Let's see if it makes a difference. In this case, very slight difference. If we've got a much bigger population and a broader bigger standard deviation, a bigger distribution in the data, it'll make more of a difference between those two. But the difference is, it does create a difference. So you have to also think, is this a sampling, in which case just use regular STDEV, or is it the entire population, in which case STDEV P, and that will give us that. Correlation, coefficient, I'm going to skip correlation. I will say, however, if you're, I'm not going to go into the stats, but if you need your R squared value, which is basically how well do your data fit a trend line, how strongly does one variable affect a change in another variable, you can just do it as RSQ and then the range. Actually, the two ranges, range 1, which is one variable, range 2, which is the other variable. So in this case, RSQ, and I'm not going to spend any time talking about the stats because I'm already looking at the time. Known Y, so this is, the range is times, comma, and S scores. So to what degree does the time of the test in this case affect the resulting score? Well, it's a R squared value of 0.36, which is kind of low, honestly. If we're below, say, a 0.7, then I'm going to say the relationship is kind of weak. So what we learned from this is the amount of time kids take on the test doesn't have much of an effect on the scores that they get. More time does not equal better scores. So those are all the big pieces, and just the two quick statistical ones. But I will ask you, and I'm willing to do it if you're willing to stick around. One of the questions I often get is, can we plot the curve? We've got all these data points. Can we make a curve to show how they're being represented? So my question is, Kendra, thanks for, can we take a little time to show how to plot those curves? Because Excel will do it. It's a little tricky, but it will do it. Let me pull up my participant list. So I guess Jennifer, Kimberly, if you want me to do it, give a thumbs up. Otherwise, I think we are good to go. So it took a little extra time to do the review because it's worth doing. Jennifer, you're good? All right. 1 is all I need. I am easy to convince. If one person says, yeah, let's do some more Excel, I'm just going to say yes without hesitation. And Kimberly, if you got a split, then I appreciate you being here, and I hope to see you in a future one also. All right, so let's take a moment and do this. How do we plot these? We have to do something tricky. But the very first thing we need to do is we need to sort the data from lowest value to highest value. Because we're going to be plotting, you got your X, Y, right? And over here is 0 in the corner. So we have to have the lowest value there, then the values get bigger. So we've got to sort. So let's go ahead and just sort time and scores. So I'm going to go up here to data, and I'm going to say sort it based on, let's see, do we have headers? Yes, we're going to sort it based on scores. So I'm going to be plotting the scores. You can't plot both at the same time, unfortunately. So you have to pick and choose, what am I actually trying to plot? So I am going to sort the scores from smallest to largest. So there's my 336, and down there is my 571. So what we're going to ask Excel to do is basically establish a probability of that particular score showing up in the data. and then plot it. So we do that with something called norm distribution. Norm distribution. And it's going to ask us a few things. First of all, what's the value that we're looking at? It's going to ask us for the average or the mean of all the scores in the range, and it's going to ask us for the standard deviation of all the scores in the range. And then it's going to say true or false. Do you want it to be a cumulative value? No, because we want a curve. It's got to be small on one end and then bigger than small on the other end. So we don't want it to keep increasing in probability, like 336 and 360 and 366 and so forth. We want to know that particular point only, so it's going to be false. So let's see how it works. And I'm going to go ahead and just blow this up a bit since we're right here. Equals norm distribution. All right, what am I looking for? I'm going to be looking for this value right next to it, which in this case is 336. Then, because I have to look at the whole range, I need to know, it says mean, average, same thing. So I'm going to look at the average of this entire range. Now it says, all right, what's the standard deviation of the range? So we know how to do that. Standard deviation. And it's going to be the same range again as scores. And then it's going to say true or false for cumulative. And we want to choose false because we want to know just that point, what's the probability is going to show up in the data, and close it. All right. So it's a very small number. Now I'm going to take that one formula and I'm going to apply it to all the other data in that set. So I'm going to just copy it down. Let me just scroll down. Where's the bottom? Right there. And I'll just copy it down. Control D to copy it down. So what I have now is the prediction or the distribution of each of those scores in the overall range. To create the curve chart, I'm simply going to graph those values. So this is the norm distribution. So let me select all of those. I will go up here to insert. For this, you want a scatter plot. You don't want bar graphs because it's going to be meaningless. You don't want line graphs. What you want is a scatter. I want to plot each and every one of those points on my graph. And let me just drag it down. And there is my curve, which, as you see in this case, is not a perfect bell curve, but it's actually not too far off. But that is how we plot the curve of our data. So we're sorting, we're doing norm distribution for each point, and then we plot those distributions, and that will give us the curve. And we can even make it a little prettier if we want to, which I will do very, very quickly here. Chart type, let's just make it smooth. There we go. Because we don't really need all the individual points. We just need to know what the overall appearance of the data are. So that is how we are going to create our bell curves or create our curves from our data. So we are quite a bit over. I appreciate you sticking with it. Kimberly, thank you. And to the other folks that have shown up today, I appreciate you all being here. Again, you can always go back to our website and see the video if you want a refresher. And I look forward to seeing you in another session. So again, David Bowman with New Mexico's Four Corners Regional Education Cooperative #1. Have a great day, and feel free to always give me a call or send me an email if you'd like a little refresher on some of these. We are here to serve. Thank you very much.